When what we want to see is beyond our sight. When it's too dangerous to go and see for ourselves. When what we want to see can't be seen in regular light. When it's so fast it seems imperceptible. When what we want to see is so small it appears invisible. That's when we turn to sensors. Right now you can see me. You can hear my voice. And if you're here beside me, you can touch the apple, smell it, and taste it. Our world is defined by what the philosopher Aristotle called our five senses. But as we use our senses to gather information, we know that there are things that our natural senses can't detect. That's when science, technology, engineering, and math can take us to the next step, to develop artificial sensors that tell us about the specifics of our world. And that's our topic for today. How sensors can work as part of an integrated system to help us solve some of our most complex problems. Let's start at the beginning. What are artificial sensors? You may not know it, but you interact with them every day. Ever walk up to a door at the grocery store and it automatically opens? Ever wonder how your camera knows when to flash? Ever use the TV remote? And how does your car know whether you have your seatbelt fastened? Sensors. How do geologists know the severity of an earthquake? How does the Hubble Space Telescope collect incredible images? And how do scientists know the makeup of pollutants in our air and water? Sensors. Sensors collect specific information that can be analyzed and acted upon. The trick is to know what information is important and what isn't. Have you ever studied for a test and been overwhelmed with too much information? Information overload happens to me all the time. Whoa! Artificial sensors not only let us know about what can't be known otherwise, they also help us use technology to sort out the relevant information from the clutter. And that lets us make important discoveries and effective decisions about our world and how we live in it. Did you know that in the southwestern part of Ohio, high-tech companies, research institutes, and the Air Force are working independently and together to take sensor technology to the next level? Local companies are developing sensor technology to assemble geographic data and create highly detailed maps. They're giving firefighters the power to see into burning buildings, and soldiers the ability to see in the dark using infrared light. They're using advanced sensors to determine the chemical makeup of the air we breathe and the water we drink. Now, it's important to understand that most sensor solutions require an integrated system. That means the sensor itself is just one part of a whole design. For example, let's take a look at the remote-controlled unmanned air vehicles. Say the Air Force needs to fly into dangerous airspace to gather real-time reconnaissance photos and video, but they don't want to risk the lives of their pilots. An unmanned aerial vehicle, or UAV, would solve the problem. But to accomplish the mission, several challenges must be overcome. First, the powerful digital cameras and encrypted radio frequency detectors necessary to collect and send the intelligence information back home have to be designed and built. These are the sensors. And then these sensors have to be integrated into a UAV suited for the mission. And someone would need to be taught how to fly the UAV. The UAV would also need power for remote flight control and to run the cameras. So specifically designed fuel cells or batteries would be needed. Well, don't forget that software needs to be written that can sift through and organize the vast amounts of data collected by the sensors on the UAV. And finally, specially trained analysts would be required to interpret the collected data. An example like this one gives you an idea of the complexity of sensor systems. Let's look at another example of how an integrated sensor system can provide solutions in difficult situations. They could have made a difference in 2005, when Hurricane Katrina destroyed much of New Orleans and severely impacted communities in 4 other Gulf states. In cases like these, high-level decision makers need to make quick decisions. Rescue personnel need to know precisely where to go first and what areas and people are in the most distress. these professionals all need situational awareness. What is situational awareness? Imagine you're playing on a school team and you're in a game, let's say basketball. As a player on the floor, you need to know where your teammates are at any given moment, and you need to know where your opponents are too. It's more than just seeing the court with your eyes. It's sensing where everyone is by using your knowledge of the game, the plays you go through in practice, knowledge of your teammates, your peripheral vision, and your multidimensional understanding of the game on the court in time and space. Now, imagine how sensor technology could have helped the city of New Orleans leaders and emergency responders improve their situational awareness. Without lights, power, or cell phones, authorities had no idea what was happening on the streets and in the Superdome and Convention Center where people had gathered. What if early helicopter responders had been equipped with infrared imaging sensors to locate stranded emergency personnel and to find fires and smoldering hotspots for firefighters? What if multispectral sensors had been available to detect gas leaks and toxic water contaminants from damaged industrial facilities that caused safety and environmental hazards? What if imaging sensors with automated processing were used to map road and transportation networks, identifying damage and determining passable routes for emergency crews? The field of sensor technology is wide open. We don't yet know all their possible uses. But they are gaining importance in the areas of medicine, space exploration, national and personal security, environment and safety, not to mention making our lives more convenient. Like this.